Hello, this is my revolutionary new way of solving square roots, okay? So, when you have a square, right, or when you're solving for square root, right, you're looking for this side, right? This side is equal to square root of x, square root of x, and then the whole square has an area of x, okay? So, now let's draw a line through that, right? Now, how do we get the area under this line, right? We need an integral, okay? So, but what is the equation of this line? It's just going to be x, like y equals x, right? So that means we do the integral from 0 to the square root of x dx, right? And that equals 1/2 of x, okay? So once you do that, right, that's only half of x, okay? So now let's just turn this into, the entirety of x. So let's just multiply it by 2, and we can just get rid of this 1/2. So that means we have this equation right here, right? But we want to get rid of the integral because, we don't know what the square root of x is. So once we get rid of the integral, we're going to have, or hold on, let's make this rigorous real quick. So d over dx, d over dx. So that means that's going to be equal to 2x. Because when you take the derivative, it removes the integral. Everyone knows that. But if you don't know that, you might not be advanced enough, or you might not have taken like several differential equation courses like I have. So 2x equals dx over dx over dx. So 2x equals 1, or no, this equation right here, when you differentiate it, it equals 2x equals 1. That's our parametric equation. Now we can, actually, yeah. Okay, so that's our equation, 2x equals 1. And now we integrate it, right? Now we integrate it from just the general antiderivative, but we got to integrate both sides, dx, because we need to get back to this form. But we got rid of the square root of the x on the upper bound of the integral because that's not important. And we're solving for the general square root. We don't care about this one or anything. So this will give us the answer to all square roots, every single one. We just need to plug in this x value, which could be anything. So the integral of 2x, that's just going to be x squared, and the integral of 1 dx, or 1, or just dx, is going to be equal to x. So x squared minus x equals the square root of x, right? And that is a very simple proof of my new revolutionary method for solving square roots. I'm pretty sure I'll be written in history books for being better than Newton, better than Einstein, even though Einstein was a physicist, but so was Newton. But Newton also solved square roots, but he didn't do it as good as me because he didn't know as much calculus as me. So thank you for watching. Make sure you like and subscribe because I need to grow this channel so I can make a lot of money and also get my revolutionary ideas out there, because it's very important to me to be famous and to also have plenty of money and fame from calculus, because that's all I see it as. Because calculus can make you a lot of money. But anyways, I need you to like and subscribe. And yeah, follow along for more important calculus videos so you can stay up to date with the newest and latest updates in calculus since Newton, because no one has really touched calculus since Newton. Leibniz, he didn't really do anything, but whatever. Newton was better than Leibniz. I'm better than Newton, so I'm like the #1 guy for calculus. So if you have any ideas, make sure you give them to me so I can steal your credit, because I'll need more ideas like this, and I can't come up with that many. So I hope you liked the video, and make sure you subscribe and like so I can make a lot of money. Alright, see ya.